Okay, we're going to continue on. This is lesson 9.6 on polygons, and this is a continuation from lesson 9.6, and we're going to be starting on page 452 and starting with number 14. So, and then we're going to go to the end of the assignment. But so if you had need a little bit of help on some of the problems, that kind of thing, or just want to have it explained again if you've been gone, this might be kind of helpful. So we're going to start with number 14, and we want to, using a little bit of algebra, we're finding out the missing angle. So we're going to use supplementary angles to find the value of x. So we have that hexagon, and then we have this straight angle, 190-degree angle, and this angle is 60 degrees. Now there's a drawing over here of a hexagon, of course, and then we want to find out what the value of x is. And we know that a supplementary angle is equal to 180 degrees. So supplementary angle equals 180 degrees. So we want to know x plus 60 degrees is equal to 180 degrees, and write that down as we go. So our missing number, we can take, and in order to find the missing number in addition problem, we want to subtract, and we end up with 120 degrees. So we know that that makes kind of sense, because we know this is an obtuse angle, and so our missing angle is 120 degrees, and so we'll put down x is equal to 120 degrees. Going on to number 15, doing the same thing. This time we have an angle. We want, again, supplementary angles, and we have this angle of 108 degrees, and we want to find the measurement of angle x. So again, x plus 108 is equal to 180 degrees, because 180 degrees is a supplementary angles. And so again, to find the missing number in an addition problem, we subtract, and if we subtract, we get 72. So if we subtract, we get 72 degrees. So x in this case is equal to 72 degrees. Going on to number 16, we're going to need to use graph paper, and we're going to graph these points on a coordinate grid and then connect them to form a polygon, and then we're going to name that polygon. So we're going to take some graph paper, and we know from number 16 that our coordinates, the largest coordinate we have is 9, excuse me. So we're going to make our coordinate grid, we're going to make it 9 by 9. So let's use a straight edge, and using graph paper, we're going to go 9 by 9. So we don't need to make it any bigger than that. So having this be 1, 2, 3, 4, 5, 6, 7, 8, 9. We know we have enough space, and we're going to count off about 9 spaces to the right as well. So again, that tells us how big we can make our graph, our grid, so we don't go off. So of course this is 0 at the bottom, and then right on the line we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Again at the right, 1, 2, 3, 4, 5, 6, 7, 8, and 9. That's the biggest we need to make that. Our first set of coordinates is 7, 3. So going to the right 7, because the first number tells us to go to the right or left. So going to the right 7, and then up 3. So we end up with right there, and then we're going to label this letter A, always capital letters. Second coordinate is 3, 3. So to the right 3, and then up 3. And we're going to label this one letter B. And again, if we go too fast, just make sure you just stop the tape and pause it so you can catch up, in case you need to go get graph paper, that kind of thing. Our next coordinate is 3, 9. So to the right 3, and then up 9. next one's 7, 8. So over to the right 7, and then up 8, right there. And then we're going to label that one letter D. And then we're going to take our straight edge, make sure you take a straight edge, and we're going to connect those dots to form our polygon. And there we go. So we made a polygon. Then we want to classify it and say what kind of a polygon it is. And since it has 4 sides, we're going to call it a quadrilateral. 4 side, because again it has 4 sides. We're going to go to number 17, and we take a look at our coordinates, and our largest coordinate is 8. So again, we're not going to make it that big, but we're going to make it so that our grid is at least 8. And so 1, 2, 3, 4, 5, 6, 7, 8. We have plenty of room there. And then over to the right again, we don't have to make it bigger than 8, so that we have enough space. So again, mark that as 0. And our first coordinate is 7, 8. Well, we get the number, I'm sorry, I forgot to number them. 1, 2, 3, 4, 5, 6, 7, 8. And because there's only 3 of them, we're going to use all these, and they're all kind of a drawing. We're going to put them all in the same, different grids. And then 1, 2, 3, 4, 5, 6, 7, 8. And again, make sure your numbers are exactly right on those lines so that we can find the intersecting point. 0, of course, being right there in the corner. And then our first coordinate is 7, 8. So going to the right 7 and up 8. And we're going to label this one letter A. And our second coordinate is, set of coordinates is 7, 3. And so 7 to the right 7 and up 3. And we're going to label that one B. And our third coordinate is 2, 5. So to the right 2 and up 5. And this is going to be letter C. And again, we take our straight edge and we connect our points. And there we go. And this polygon, of course, is called a triangle because it has 3 sides. A 3-sided figure has a triangle. Now number 18, you're going to go ahead and do number 18. The largest number is 10, so make sure that your coordinate grid is at least 10 by 10. Everything is done with a straight edge, and so we're going to let you go on, and you can pause it at this time to stop and do number 18. I'm going to keep going, however, and so since you did number 6 through 18 on the graph paper, so graph paper, we're going to go on to number 19. Number 19 is, we're going to use this table, so we're going to copy and complete the table. So again, use your straight edge. We're just going to make this table, we'll use the lines, but we're going to copy the line, copy this down, we're going to make it 2 rows and leave it open at the end for right now so we can add to it. The first one is the number of sides of a regular polygon, and the bottom one is the number of diagonals in a regular polygon. So we're going to leave we started with the table saying, okay, we have 4 sides. If a polygon has 4 sides, so for example, let's draw a regular polygon with 4 sides, which has 4 equal sides, 4 equal angles. So, and we know it because all these are the same, we have what is called a square. And we want to know how many diagonals we can draw. So basically we can draw 1 diagonal. So fill that in. And then we have 5 and 6. We keep going here. Take my straight edge and just extend this out just a little bit more. There we go. if we have a 5-sided regular polygon? So again, we know this is a pentagon by now, and make it as equal as you can. So 5 equal sides, equal angles, and we want to know how many diagonals we can make from one vertex. So we have 1, 2. And then the next one is a hexagon, so a 6-sided figure. 3, 4, 5, and 6. And this one here, again, you have to kind of work with it a little bit to make it as regular as you can. So a regular polygon with 6 sides, so 1, 2, 3. In this case, we can make 3 diagonals. And I think that fills out our chart. Now number 20, I know it said in the assignment that you didn't have to do number 20, but we're going to continue on with number 20 because we're looking for a pattern. And we want to know, how does the number of diagonals from one vertex change as the number of sides increases? So what happens for every time we move up and we add a number of sides, the number of diagonals increases. So we can kind of predict that if we have a polygon with 7 sides, we know from our pattern that our diagonals is going to also increase by 1, which is going to be 4. And we can draw that if you want to, just find it out. So basically, the number of diagonals increase by 1 as the sides increase by 1. So we went up by 1 here, and then we went basically our pattern followed the same. Number 21, we want to predict what the pattern, so use the pattern we found in number 20 to predict the number of diagonals that we would have from a regular polygon with 9 sides. So see if you can think about this. If we changed it from 8, predict a little bit, let's keep this going. So if we had 8 sides, how many diagonals would there be if we follow the same pattern? If you said 5, you are exactly correct. How about if we had 9 sides? How many diagonals would there be? And again, if you said 6, you are exactly right. So for number 21, our answer, of course, is 6 diagonals. Now number 22, again, this wasn't part of your assignment, but we're going to continue on with this. Number 22, what type of polygon has no diagonals? Absolutely no diagonals. Think about this. Hexagon has 3, a pentagon has 2, a square has 1, and so what would have 0 if we work backwards? And if you said a triangle, you are exactly right, because there is no way that we can make a diagonal. Now number 20, we're going to skip number 23 and we're going to go to number 24, and we're going to draw, this is part of your assignment, was to draw number 24. So you're going to take a look at number 24, and it has 5 sides. We want to find the perimeter of a regular pentagon, which is a 5-sided figure. So let's draw that 5-sided figure. Okay, and it's a regular one, so we're going to pretend for a moment it has 5 equal sides, 5 equal angles, so 5 sides. And we know that the perimeter, the whole distance around the outside edge, is equal to 45 inches. And so we want to know is how long is each, since it has 5 sides, how many inches is each side equal to? So we know to find perimeter we have to basically 5 times what would equal 45. So 5 times, and if you said 9, you are correct, 5 times 9 is equal to 45 inches. And we want to make sure we label that 9 inches. So each side is equal to 9 inches.